today we are looking at truth tables. So in class, we looked at truth values of a conditional statement. And I gave the example, if you clean your room, then you can go to the football game. And so when we analyzed that, we said that if you clean your room, you should be expected to go to the football game. So if you clean your room, true, and your mom doesn't let you go to the football game, we'd have a problem on our hands, right? And that is, she said, if you clean your room, you can go to the football game. You clean your room. If she doesn't let you go to the football game, that's a problem. So that is false. That has broken the promise of the conditional statement. Otherwise, though, if you don't clean your room and you don't go to the football game, okay, well, that makes sense. That's true. That matches what the conditional says. If you don't clean your room and you go to the football game, well, that could happen. She didn't say only if you clean your room, but maybe she changes her mind, or she says you can do it tomorrow, or something like that. So that's still, it didn't break the promise of the conditional statement. And then obviously, if you clean your room and go to the football game, that makes that conditional true. So notice, like it says right here, the only time a conditional statement is false is when the hypothesis is true and the conclusion is false, because the whole conditional statement means if you do the hypothesis, we expect the conclusion to happen. So if the conclusion does not happen, then the overall truth value is false. I like their example here where a truth table is like a business contract. They have, let's say, suppose it says, let the hypothesis be you worked 1 hour, and the conclusion be you get paid $17. And so I like their analogy too, because initially, true means you worked 1 hour, you got paid. Perfect. But if you worked 1 hour and you didn't get paid, we would have a problem, right? They broke their contract, not good. Boo. So that is the only false. But otherwise, hey, you didn't work 1 hour, but you still got paid $17. Hey, perfect. Maybe you didn't work the whole hour or something, but you still made money. Everything's good. And then obviously, if you don't work and you don't get paid, well, it makes sense that you didn't get paid if you didn't work. So this is what we need to remember. You only need to remember that one thing, and that is when it's true, then false. If your hypothesis is true and your conclusion is false, then it's false. Otherwise, it's true. So let's look at some truth tables here. We're going to do the first 5 together. So numbers 1, 2, and 3 are all the same. It's just if P, then Q. Do you see that? But what they're testing you on is the true and falses for P and Q can be mixed up. See how all these right here are not the same? All 4 combinations are there. In other words, true, 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 false, false, true, and false, false. All 4 combinations are there, but they're in different orders. So remember, the one we have to look out for is right here. If true, then false. And so that is our false. And once we find that, the other 3 are true. Same thing on number 2. Where do we have, oh, here it is, true, then false. That's our false. The rest of them are true. Where is that true, then false? Boom, right there. That's false. The rest of them are true. But obviously things are going to get more complicated. And if we look at number 4, they actually analyze all forms of the conditional equation. We have, you know what? Oh, no. Oh, I am recording. Okay, sorry. For a minute there, I thought I wasn't recording. So all forms of the conditional equation. Notice they already did the one we just practiced 3 times for us, okay? And we can see when we have that true, then false, it's false. Now let's analyze the converse. So that is if Q, then P. So I think it's good. Here's our Q, here's your P. So if Q true, then P true, that's true. If Q, which is false, then P true, that's true. If Q true implies P false, that's our false one. And then if false, then false is true. So you can see these are different than the conditional. Now we have not P. So P over here at the far left are P values. So if P is true, what do you think not P would be? Well, kind of the opposite of true, right? If it's not true, then it's false. And if it's not true, then it's false. And if it's not false, then it's true. And if not false, then it's true. So we were looking at all these right here and basically doing the opposite. Now we want to look at Q because we need not Q. So the opposite of true is false. The opposite of false is true. The opposite of true is false. The opposite of false is true. Now we are going to be able to calculate the inverse. Notice, before we could do the inverse, we needed to know what's not P and what's not Q. So we needed to make columns for those. So we had those truth values before we do the inverse. So these all go kind of this way. So if false, then false is true. If false, then true, true. If true, then false, false. If true, then true, true. Now for the contrapositive, we have to do the reverse. So when we can't just see it on the chart, but we have to do the reverse, I usually write it. If false, then false, true. If true, then false, okay, because we're going not Q and then not P. That's our false. If false, then true, true. And if true, then true, true. One more example, and then you'll be doing the rest for homework. For number 5, we have our initial conditional statement. So if false, then false, true. If true, then true, true. If true, then false, false. If false, then true, true. Now notice this not is in front of our conditional equation. So that not does not distribute to that parenthesis. But we have to think it's the opposite of what we just found. Notice whatever's in the parenthesis is in the column before it. And then we can analyze the not. And so if it's not P implies Q, or it's not that initial truth value, all of these are going to be the opposite of what the previous column was, because it's not whatever the previous column said. Now, if you're in applied, stop the video right now. If you're in honors, stay tuned because you're going to have to try some of your own. So let's suppose we were making a truth table for not, let's see, P implies not Q. So we would start with P and Q, and then we'll start with that, right? We'll just start with that right now. So you can do this however you want. I just always do it this way. But as long as you have all 4 combinations, that's all that matters. But then, notice our statement above, we need not Q. We don't need not P, but we need not Q. So I'm going to do, my next column is going to be not Q. And not Q is going to be the opposite of my Q column, so it's going to be false, true, false, true. All right? Now, we need what's inside here. So that's going to be my next column. P implies not Q. So if that's my next column, I'm using my P and my not Q. So true implies false. That's our bad one, right? False. True implies true. True. False implies false. True. And false implies true. True. Now, my final column is exactly what I want to know. And notice it's the not or the opposite of the column we just did. That's how you have to build it yourself. And so we're going to look at all these truth values in this column and do the opposite. And that will be, that's the full truth value for that conditional statement, or that statement we should just say. And you can see now how you have to build it so that you have all the parts you need. It builds up to do that final one. So we'll get more practice with that in class, warm-up problems and so forth. But you will be expected on the next test to make your own truth table, like this example here.